Alrighty, so I'm going to talk about Fedora CoreOS. A lot of you probably know what Fedora is, but some of you might not know what CoreOS is. I'm going to talk a little bit about that. So, who am I? My name's Jacob Highfield. I'm a fourth year. Um, well, I'm currently the scoring lead for RITSEC and ISTS. I'm an Arch Linux user, by the way. I pretty much go to all the hockey games. I'm a very big hockey enjoyer around here. I play the saxophone in a pep band. You can usually find me at hockey games. Just look for the tiger duct taped to a bucket hat in the pep band, and that's me. I also have 2 dogs at home, so here's the dog tax. They're sometimes annoying, but I love them to death. So first, before we can talk about Fedora CoreOS, just to make sure everyone's on the same page, we first have to talk about what is Fedora. Fedora is a Linux distribution. It's sponsored mainly by Red Hat. Sometimes it's known as the RHEL testing ground. Fedora usually likes to stay pretty fast-paced. They do a lot of changes and try to keep up with new technologies, such as using Btrfs. And I think they were one of the first distros to switch to Systemd when that was new. They use a semi-rolling release, where they do a release every 6 months, while holding back core system packages like the desktop, if you use their workstation in the kernel until the next release. And it comes in a multitude of different flavors. They have a workstation distro, they have a server distro, they have a container image, and they also have CoreOS. So what's CoreOS? CoreOS, it's based on the rock-solid Fedora base. Basically, it is a read-only operating system designed for container workloads. This includes Podman, Docker, Kubernetes, or pretty much anything you want to throw at it. But mainly, it's designed for containers. For its package space, it uses what's called OS tree. Which is the same technology used by Flatpak. So basically, you can think of it like a Git repository, but for software instead of source code. And then it does automatic updating and can roll back if anything breaks, because that file system is immutable and stuff is pushed down through essentially tags, like tags in the Git repository. So that sounds cool. Let's give CoreOS a shot in a VM. We're going to install it. So let me just go to their installation page, and wow, that's a lot of images. Well, given that I'm testing this, I kind of want to get the 0 to install experience. So we're going to go with the bare metal ISO way up there. Wow, it's the first one. That was easy. So let's install it. Let's boot it up, and I get hit with this. That's not helpful. Where's the installer? Well, let's look at this real quick. So this is a little bit of the output that you saw. You'll see on the left there, it says ignition. It ran this boot. There was no config provided by the user. There's no keys provided by ignition. So yeah. So ignition is where the fun begins. So this is where the real fun and magic of CoreOS begins. We love ignition. You can think of ignition as basically, if you've ever used an answer file in Windows, that's what this is. It does provisioning of the operating system on first boot. So you can set all sorts of stuff up. You can have you can do Systemd services. You can drop files on the box, and because of just everything is declared in a configuration file, you can make really easy declarable and repeatable deployments of the same exact CoreOS box. So you can also add users and give them passwords, give them drop SSH keys. You can do all sorts of stuff with Ignition. So we're going to talk a little bit about deploying Systemd services, because that's the big one. You can write a custom Systemd service, which you can then enable it, and it will start on boot. This is the main way that you can layer packages on Fedora CoreOS. Since the base root file system is immutable, in order to get more system packages, you have to do what's called layer them. So for example, if you want to add tail scale, you have to layer it to the base, on top of the base image. And then Podman has this really cool feature called Quadlet, where if you drop a file in a certain place, it will it'll generate a systemd service and start and manage a container for you, including automatic updating if you so wish, which is really cool. If you want to run any command you want during first boot, you make a systemd service, and that's how you do it. The possibilities are endless. So what does an ignition file look like? Because, you know, you got to write this thing. It looks like this. That's kind of gross. Who wants to write that? I don't want to write that. So can we use a more readable format, please? Well, maybe something like this. Wow, that's a lot better. I can actually read that. I want to write that. So what is that? Well, that's Butane. Butane is a transpiler that can take a YAML configuration and turn it into the JSON configuration that Ignition expects. Now, as much as I dislike YAML because it's a very bloated spec in my opinion, this is very readable and very writable. And one other cool feature you can use with Butane is that you can reference external files, which allows for easy organization. So let's say if you have like 10 services you want to add to the box, instead of including all 10 services in a single config, you just say, hey, this service is in this file, this service is this file, this service is this file. And you can also include binary data such as images, tarballs, whatever you want. And it base 64 encodes it, and it adds it to the Ignition config. So let's look at a little bit of the Ignition pipeline real quick. So you have your Butane file, which is this nice YAML looking, and you can set a user, you can give it a password hash, a systemd service right there. In that example, the systemd service is in line with the file. And you use Butane to turn it into that first Ignition file we saw. Then once you have that Ignition file, you pipe it into CoreOS, it boots, and it automatically provisions all of the settings that you've defined. So one really cool way you can use this is you can use OpenTofu or Terraform. And so those you're familiar, if you're familiar with OpenTofu or Terraform, you can use those to deploy all sorts of cloud instances in DigitalOcean, Azure, AWS, Google Cloud, even OpenStack. They have a provider for that. But not only can you use OpenTofu and Terraform to provision those, but you can put a little Fedora CoreOS Ignition file in there. It'll automatically provision the OS for you, removing a lot of Ansible you'd otherwise need to run. So basically you can do it all in Terraform, which is really cool. So, but what about system maintenance? Because, well, once you install it, okay, how do I keep it up to date? How do I make sure everything's running smoothly? Well, with CoreOS, you just don't. It just does it for you. It's awesome. So updates are automatically pushed through what's called a Cincinnati server. By default, the Fedora upstream project runs their own server, which your CoreOS box will connect to and say, hey, is there any new updates? And the Cincinnati server will say, yes, there's an update, and it will start pulling immediately. Or it'll say, nope, there's no update, and it'll wait again. The Cincinnati server is really cool in a sense that you can deploy it on-prem if you have a cluster of CoreOS nodes. And you can then do staged rollouts of the new CoreOS images as they come out. And then let's say, for example, if something breaks during the update, because it's an update, if you've seen Windows, that breaks all the time. But with CoreOS, if something breaks, there's always the possibility that you can roll back to the previous version that did work. Super easy. You just go in, you use RPM OS tree rollback, and it rolls back to the previous version upon reboot. So now that we've gone a little bit through what CoreOS is and all the cool tech behind it, let's do a little bit of a demo. I'm going to show you. I got three demos, 3 CoreOS boxes on my Proxmox node that I run myself. So all 3 of these have 3 different configurations with Ignition. This first one here is a really basic config. It's a really basic config. I'm going to start it up here. I'll go to console. Actually, we'll do this. So it's going to boot up. And you're going to notice while it's booting up, it's going to reboot twice. This configuration is really simple. All it does is it adds a password hash to the core user, so that way I can log in and actually take a peek around. And then the second one is that it layers the QEMU guest agent on top, because for some reason the QEMU image does not include the guest agent. I don't know why. Probably a limitation with their build infrastructure, but we'll let it sit here for a bit. The way it works is in order to layer packages on top of the base, you have to reboot the system once the package installs. So it's going to grab the QEMU guest agent, layer it on top, reboot, and then once that occurs, Zincanti, which is responsible for doing automatic updates, will say, hey, there's a new image, and it'll pull that down and reboot again. So there's the first reboot. The core user's already been provisioned. If you noticed on the first boot, there was no orange text at the top. It was all white, which means that the SSH keys were applied. It wasn't warning you saying, hey, there's no config. So that's fun. That is fun. Wow, okay. Anyway, that was the first reboot. So we're gonna wait a little bit again, because otherwise it'll reboot on me. And then currently you can see up there, I don't know if you can see that well, it's currently running version 2024-10.27. I purposefully grabbed an older image just to show off the auto updates. That way we can roll back if needed, or just show off the rollback capabilities too. There it goes. It looks like it's rebooting again. Yeah, there it goes. Okay. So we'll let it reboot a second time. If you saw there for a split second under grub, you could see there were 2 entries. That allows you to, let's say for some reason the active entry just isn't booting for some reason, and it's not automatically going back. You can manually go into grub and select the other option. So it looks like we finished the reboot. So we're now on version 2025, January 5th. Awesome. So we're going to log into Core here with the super secure password. Yes, I did that. That's fun. So we're logged in. Yeah. So if we look at our PMOS tree, this is kind of hard with on one hand. Oops. Did I just hope I didn't screw it up? Okay. So as you can see, we got 2 images. We got the top one, which is the current one we're booting. You can see that on the left there by a square next to it. And then the bottom one is the one that we initially started with. And actually, as you can see, both images have the QEMU guest agent layered on top. So that's cool. So just for funsies, we're going to simulate a rollback. For example, let's say this update just isn't working. I want to go back to how it was. We're just going to roll back. There it goes. So as you can see, all of that stuff just got rolled back. So if I reboot the box, wait for it to boot again, it will roll back to the 2024, October 2024 image that we had initially. And hey, that one worked. Well, let's say hypothetically the newer one did not. And what's really nice is I'm pretty sure this will stick. I actually haven't tested this. This should stick until the next image gets rolled out, in which case it'll then automatically apply that new image, and hopefully that your bug is fixed by then. So that's just a basic intro to CoreOS. I provisioned a password. I layered the QEMU agent on top. Move this over here. Cool. Okay. So now we're going to look at the next one, which I'm going to shut this one down first. This one I have set up so that it's a config that automatically, Drew just gave a great presentation on this. I don't see him in here though. Sad. He just gave a great presentation on Tailscale. And what this one will do is it will boot up the box. It'll do the same things as the previous one, but it's also going to layer on top, Tailscale on top. So we'll see an additional reboot as it does that. And then it'll also authenticate with Tailscale, which will then pop up in my telnet. So if we make this a little bigger. So first boot, it's either it'll choose one of the two. I have two services. One of them installs a guest agent. One of them does Tailscale. It'll pick one of them. And the way I have the system D services set up, it will not attempt to authenticate until the installation occurs. You don't want to do it the other way. That's pretty bad. While that's going, I wonder if, I'm going to just see if I can switch this over to, no, not that. My desktop. Yeah, okay. So I'll put that down there. So it's rebooting again. I'm gonna wait for this to go through. So actually, that's what I was gonna do. I was gonna pull up the configs. So the core user looks like this. This is a basic one. Let me open it in Vim instead. Okay, no, I can't type. Good to know. So that was the first reboot in the background, in case you didn't see that. So either install the QEMU guest agent or Tailscale. So this is the first config. All it did, as you see there, password hash, SSH key, and then the guest agent service. That's all the first one did. So we'll quit Vim, and we'll open the Tailscale one. If I can type. So this is the second one. As you can see, we got the password hash again, the SSH key, and then Tailscale. The way they pushed out Tailscale is through their own repo. So here I'm just dropping the file onto the box with the Tailscale repo, and then I also set the host name. Something I forgot to do with the last one, but hey, we'll do it now, especially since I'm connected to a network, which is the Tailnet. And then here we have two new services. We have install Tailscale, which layers the Tailscale package on top, and then a Tailscale auth service, which that currently has a Tailscale auth key. What you can do with Tailscale is you can generate an auth key, which when you do Tailscale up with that auth key, it'll automatically authenticate that box with your Tailnet and add it to the your Tailnet. You can add tags. You can make it empirical. So once the box disconnects from the internet or Tailscale, it gets removed from your Tailnet. All sorts of fun stuff. So I just have a tag that puts it under a pretty restrictive ACL because it's just a demo, and I do use my Tailnet. But if we look at the box now, let's see, it did finish. Okay, so if I could actually, yes. Okay, so now we have the box. It's finished booting. If we do Tailscale status, there's no shell completions. You'll see that it is connected to Tailnet, and those are my personal devices. You can't see any of my other stuff because of the ACL, but you can see it is connected, it automatically authenticated to the Tailnet. So, wow, I can spin up a CoreOS box with Tailnet, with Tailscale already provisioned. That is super helpful. So that way you don't have to go in and manually configure Tailscale. You just spin the box up. So that's really cool. What if we take this one step further and put a web server on here? That would be really cool. So that's exactly what we're going to do. I'm gonna shut this box down, and we're going over to this one. And this one, same exact one as the Tailscale one, except now there's a web server on it. So we'll let it go through again. Close that one. So we'll let it go through again. Let me pull up the config for the web server one. A lot of stuff in here. Yeah, there it is. Okay. So this one, it's a lot bigger. So we got the core user, we got the host name, we got the Tailscale repo, but then we have 3 new files here. Specifically, a couple new files here actually. We have caddy.container, and that is getting placed in etc containers systemd, that folder. That is where Quadlet looks to look for container configuration files. You put a file in there, and it will look at that. It will read that file and turn it into a systemd service, which then systemd will then manage the containers, starting and stopping the container, while podman under the hood is what's actually running the container. And you can also do this in rootless mode. So you get all the benefits of using podman instead of in its rootless mode. Some volumes which go with the caddy container, and then a little caddy file, just so you can actually use caddy. And then these 2 here is just an index file from one of my sites, your.cringe.fyi. Yes, that is real. Yes, you can go to it. And then it grabs the index file. So I'm just cloning my web server essentially for this demo. So it's going to grab the index file, and it's going to grab the corresponding GIF that goes with it. Because, well, while you can include binary data in an ignition config, if you pipe that, one of the things I found while testing this is if you put that in the QEMU config, which is how you provision CoreOS with QEMU, you put it in a little parameter. It is very slow. Like after 90 seconds, and it only copied 600 kilobytes slow, and I was not waiting for a 16 megabyte file to transfer. So you can with Butane and Ignition, you can have it just grab files from the internet, check the hash, and if it matches, use that instead, which helps speed up deployment very quickly. And then the rest is just what we expect. It's the same. It does the tailscale auth, tailscale, and the guest agent. So I think it's almost ready. Yes, it is. It is now ready. So now that we have the box is ready, so it's already on my tailnet, which means I should be able to, actually, I think I just remembered something. Oh no, lots of stuff. I need to remove the old box and rename the new box, or else it's not going to be happy. Yes. Cool. Rename. Come on. Okay. So now that we have that, we can now go to CoreOS demo. And as you can see, I've tested this already. And there you go. POV, you are cringe. We have a web server running, we have the Caddy web server running on Fedora CoreOS, automatically provisioned. I didn't have to touch a single thing. And that's all I have. Any questions? I know you have a question. I know you do. But does anyone have any serious questions about CoreOS? Yes. So I have used Nix. I have tested NixOS a little bit. The one thing I like about Fedora CoreOS is that it's based off Fedora. So if you already know Fedora, it's a great stepping stone from going from Fedora to more container platforms. The thing with NixOS, the thing with Fedora, it also does like SE Linux and all this other security hardening, and it's backed by Red Hat. NixOS is more of a community project, but if you like using NixOS, then by all means, go for it. When I used NixOS, I did like it at first until I started messing with it, and just a couple things I didn't like about it. If I thought about it a little bit more, I could name them, but not right now. But both options are great. I like CoreOS because I've been thinking about using CoreOS because it's built for containers. I want to use containers. And just for the stream, the question was, why would you use this over NixOS? I forgot to say that. So yeah, both are great options, but Fedora CoreOS is more heavily used is more geared towards containers.